center of how these institutions function, because they need to analyze the societal problems, tell the researchers, tell the engineers, this is how you can solve the farmers problem. They are looking for these sort of technologies, and what is the social kind of aspects, and how you can make that technology benefit them. A lot of things. So these are things which are required, and picking problems from the industry. That is where academia industry collaborations are very important. We again did multiple things there. We created multiple centers of excellence at IIT Delhi with industry professionals. We also started these professors of practice. The professors of practice are the positions where 10% of our faculty in any department can be professors of practice. Meaning, if we have 700 faculty, 70 faculty in the institute can be professors of practice. They don't even need a PhD. But only thing we expect the professors of practice to have is they must be experts at something by virtue of them working in an industry, to for a very long period of time, that they have been working in that area and they are experts in that industry, in that particular space, but they don't have a PhD, which is okay. So they can become professors of practice with us. They can become adjunct professors of practice with us. So now we have already started recruiting multiple people from industries as professors of practice. The joint appointments with industry sabbaticals for faculty. The FIRE is another scheme which I am very proud of, but it is called Faculty Innovation and Research Driven Entrepreneurship. So when I say faculty innovation and research driven entrepreneurship, we are trying to turn our faculty into entrepreneurs. How are we doing that? We give them 50 lakh rupees grant. If a faculty member says, I have developed a technology and I want to start a company out of it, institute, after a rigorous review, gives that faculty member 50 lakh rupees as a grant, gives 1 year of sabbatical. You can take leave out from your job, fully paid leave, and for 1 year you can work on your idea to convert that into a company. If you need more time, you can combine that 1 year of leave to 2 years of unpaid leave, the lean as we call it. So they can take 3 years of time away from their job, build that company and come back and become professors again. So we are also, the FIRE scheme is something where we are turning our faculty into entrepreneurs. And even the PhD incubator, this is a platform for harnessing deep technologies. Here again, many of our PhDs don't get into entrepreneurship. Most of the entrepreneurship in the country today is happening out of the undergraduate students, the BTechs kind of a thing. But BTechs don't have the depth required, to solve any deep tech kind of issues. And most of their innovation tends to be in aggregation kind of a model, e-commerce kind of things. Those sort of things they do very well. But if you have to solve, develop a diagnostic kit for, some particular disease, with a BTech degree, you won't be able to do that. You need, people with a PhD degree to be working and then developing those solutions and eventually become entrepreneurs to take that to the market. So these are again things which are required to be done. Other way to pick up problems is strategic agencies. We have very successful models in space. The ISRO is always considered to be very successful in space. ISRO is one of the largest space agencies in the world. every sector, right? Whether it is healthcare or atmosphere or bioinformatics, everywhere you will see AI technology is becoming popular. So we need to, at IIT Delhi, we started a school of AI, which is now trying to recruit faculty from diverse disciplines and see how we can apply these AI technologies, techniques to multiple domains. So this again, it requires a lot of scale up of our research and also multidisciplinary involvement in conducting the cognitive technology research, because we can't leave AI ML to computer scientists alone. And finally, the quantum technology, which is again, everybody is talking of the future quantum computers, and all the cryptography technologies are going to undergo significant advancement. And nanoparticles are going to become nanotechnology principles. In the next 20 minutes that I have, I will talk about what is nanotechnology and what we can do. I think, as you all know, nanotechnology is going in dimensions, small dimensions, and once you go to particle sizes which are like 5 nanometers, 10 nanometers, the surface to volume ratios become very high. The particles will exhibit new properties because of the changes in the surface to volume ratios, but also because of the changes in the way these materials interact with each other at the nanoscale. Now you see thermal, mechanical, optical properties change at the nanoscale. So therefore, you have new properties, at the nanoscale for all these known materials, and you also have large surface areas. And using some of these, for example, the surface area when I mentioned, you can on a 1 centimeter by 1 centimeter chip, you can create surface area which could be equivalent to that of a football field. Those sort of possibilities exist with the nanotechnology. So therefore, the future is wide open when it comes to nanotechnology. Even as a science, it is evolving very fast. Studying nanoscience, studying the effects of the size scaling. When a 5 nanometer particle or a 100 nanometer particle behave very differently. So how that size dependence affects the physical, optical, chemical, and all of these properties is a great science. And making use of those changes in properties for an application, for an engineering application, is another great opportunity that we have in the nanotechnology space. So now using this, so what kind of problems can we work on? For example, since we are talking about sensors, I always give this example. So there are 5 senses, right? We usually know about sight, hearing, touch, taste, and smell. These are the 5 senses that we commonly know. You ask any student, any child, they say we have 5 senses. And but there is also another 6th sense, which is called proprioception. The proprioception is something which is which tells the body about its position. When the it tells you, what is your position with relation to whatever is around you. But this is equivalent to the GPS basically. So now if you take that, we have 6 senses, and out of the 6 senses, the 4 are already there in your mobile phone. A mobile phone also notes its location, right? There are good GPS systems now. Mobile phones can also see very well. They have excellent cameras. Mobile phones also can hear very well. They have excellent microphones. They we developed a lead-free piezoelectric material based on halides, the perovskite, and so this we reported recently in the soil health cards, and but it requires a lot of micro and macronutrients to be measured by the farmer in order to monitor what is happening to the field. And but where will the farmer go and get all these tests done? It has to be done in agricultural labs, and it costs money. They are not easily available. It takes time. So we said, can we develop simple low cost sensing platforms with which somebody in the village, somebody 10th class graduate trained to use these simple technologies, goes to the farm and then fills up all the numbers here based on the tests which are conducted in the farm itself. So we started looking at developing sensors for these, and we started it as a project between IIT Delhi and IIT Bombay, because I moved to IIT Delhi about 5 years ago. So 4 prototypes. So again, the top-down planning is key. So the pathogen detection, moisture, pH and salinity, micro and macronutrients, volatile tracking on the platform, and all of this can be easily published. But before we publish anything, we file a patent, we protect the IP, then publish the paper, and then putting it all together, we develop a prototype. That has been my approach to doing science now for the past few years. And we again have all these prototypes available now for farmers. So this, we started a company, SoilSense, out of this. Now these products are all available for farmers. Now they are negotiating with someone for almost 20,000 these devices for large farms and all of that. So these are the soil health monitoring stations. So this is, you can do the complete health monitoring of soil using these technologies. And so they have been working on multiple crops, multiple crop cycles, save water, improve the yield. So they are working on many of these technologies. And then even the NPK detection we have done now. We can detect NPK using some of these sensors. So much of my work now ends up as prototypes. And then we have 2 startups. I have 2 startups now. One is NanoSniff. In fact, they are no longer a startup. They were able to completely commercialize the platform that we developed as OmniCant. Now explosive detector is their flagship product, which is what now they are selling all over the world. And iSens, the cardiac diagnostic system, is what they will take up once they are done with the complete marketing and all of this. So therefore, this is a successful company now. And then the second one is SoilSense. SoilSense is 3 years old. They are also doing very well. They are working with doing a lot of pilots with all of these people. They are selling technologies now to farmers. You can again buy them on the government e-marketplace. So therefore, what is the relevance and delivery if you keep in mind, and if you also work in a top-down fashion, that you identify and visualize a product that is required, and you work in a top-down fashion, you can write lots of papers, you can file many patents. At the end of some period of time, all of this takes time. These are all, each one of the projects that I have said. The explosive detector, we spent 8 to 10 years in actually taking it from an idea stage to market. I know that took us almost 10 years. And the agricultural sensors, we were able to do that in about 4 years time, because we have learned many of those tricks now much better. So agricultural sensors, it took us something like 4 years time. So you can keep getting better, and you can work on the platform development where you can write papers and you can perfect that platform before thinking of a product. But you need to protect IP as early as possible. So if you don't file patents, if you only keep publishing papers, you will never be able to eventually start a company or commercialize any of those technologies, because once it is in public domain, then it belongs to everyone. So India doesn't even allow any patenting once you publish it. US, within 1 year, you can still file a patent even after publication. So and you also now there are lots of Government of India schemes for startups. So therefore you can mature your technology in the academic environment, and then and then once it is mature, then you can start a company and start selling things. So you should not start companies, just because we have an idea, because once you start a company, funding becomes a problem. In academia, you can generate that funding more easily. So therefore, you should mature it in academic environment, and then start a company to sell the products. And you need to use the government sources of funding for doing all of that. And professors and students alone can't build a company, because we are all technology people. Our way of looking at things is very different. You always need an industry partner. You need an entrepreneur who has done that before. He might have failed, which doesn't matter. He or she might have failed, doesn't matter, but that experience is very important. Your team should have faculty members, students, and then these entrepreneurs or industry professionals who are all working together if you want to build a company out of these technologies. So the team is very important. And you need to also work towards the value of equity rather than fighting for equity, because every time I see people starting a company, immediately how much equity each one should have, and no two founders will be on talking terms once the company becomes successful. So I see a lot of our alumni also here, and they were close friends, started these companies. Now the companies are doing well, but after a while they just can't be in the same room, so you have to call them on different days, kind of a thing. So that's because all those things will come into picture. We are all humans, so therefore you need to have proper agreements in place, ensure that you may be the closest friends, but everything should be perfectly documented, and everything should be clear. What if somebody leaves in between? How much of equity that person will take away? All of these things need to be thought about from the beginning itself. And then you must involve students in the enterprise, and that's a very strong motivation for them. There are a lot of things where you have a great domestic demand, and I think you should innovate in areas where there are such demands available. And then I call these 3 P's: passion, patience, and perseverance. So you all the nothing will happen if you are not passionate. 9 to 5 kind of a jobs or for people in administrative kind of a thing. But if you are a researcher, if you want to do all of it, most of us put in 14 to 16 hours in a day. So I think unless you work that like that, unless your mind is always occupied with the problem you are solving, no, I don't think any of this will really happen. So I think you may be doing something, but your mind is always thinking of a problem that you want to solve, kind of a thing. So that sort of passion you need to see, and you need a lot of patience. Nothing is going to happen overnight. It takes 8 to 10 years from an idea to a product. And if you are experienced enough, it can take at least still 3 to 5 years of time frame. Even for big industries like Intel's and all of them, when they start a concept, by the time it goes to market, it is pretty long time. So therefore you need that kind of a patience, and you also need perseverance, because there will be infinite reasons why you want to give up. And if any of those reasons become valid, then you would have given up in between. So I would call these 3 P's are very, very important for you if you want to take things all the way to the final kind of stages. Like I was saying, the patenting problem, we are not filing enough patents. I looked at the 2019 data for nanotechnology, which I am aware of. Just look at where India is. India is now at the 3rd position. Papers, number of publications in nanotechnology: China 74,000 papers, US 23,000, India 15,000. So we are at the 3rd position. Look at the patents now. Of course, China is also like us, but look at US. For 23,000 papers, they have filed 4,600 patents. You look at India, 15,000 papers, 54 patents. US files 1 patent for every 5 papers. If a researcher is writing 5 papers, they know that they have a technology which they have to protect. India, for every 300 papers, we tend to file 1 patent. I think with that kind of a attitude, with that kind of publication to patent ratio, nothing is going to happen. You will only be generating knowledge, but somebody else will use that knowledge, but you will never be able to make anything out of that. So I think we need to file more patents. The sequence needs to be always patent, publish, and then prosper. So the 3 P's need to go in the same sequence. So you first file a patent, and then you publish it, and then you take it to the next level. And India has opportunities. There are even all these multinational companies are just scratching the surface. There are so many unmet needs right now where you can work on, and we are all picking problems from journals from North America, Europe, and all that. I think we need to innovate in areas where there is a great domestic demand. Any of the problems I mentioned are deep science. You can write tons of papers, you can file any number of patents, and so therefore it's not that if you are doing this kind of research, your research quality will be low, or you will not get recognitions, or there's nothing like that. You can actually write as many papers as anybody else, but when all those papers are put together, you will be able to even demonstrate something which is tangible, something which we can call an innovation. And local R&D for product development is absolutely essential. The explosive detector product that we developed, it now costs 1/5 of what is commercially available, and its maintenance costs are also 1/5. Now they can win any bid, in any open market, hands down. Nobody can compete with the technology anywhere in the world. So that is a kind of a advantage you will have if you do the local R&D for these developments. It's possible to do high quality research in academic institutions, yet make it relevant to India's needs. Basic science is very important. In IITs and IASC and in ISER, our top institutions, if we do innovation which is not based on science, it's all jugaad. That nobody respects you for doing. So your innovations need to be based on science, which are backed up by good publications that you have from your group. So therefore, I think it is never one versus the other. So for many of us engineers, it has to be based on basic science. From science will arise technology. From technology will come products and prototypes. Therefore, we never must underestimate the power of science. So from science, but that mindset is important. The design thinking process is important. And once we do that, I always say that the creativity in our higher education sector is as important as literacy at the grassroots level. I think that we need to keep in mind. And India has a bright future because we have some of the brightest scientists in India. Working out of India now. Many are returning in good institutions, but other than publishing papers, they are not looking anything beyond. And these days, since everybody is asking for patents, they are just filing some patents, but nobody really cares what is happening to these patents. So I think that mindset needs to change. If you do that top-down thing, keep the problem-oriented approach. If you want, keep in mind that I want to develop the complete prototype. At the end of the day, the multidisciplinary research automatically comes. You don't even have to plan for anything like that, because if I have to develop a complete prototype, I cannot do that with my understanding alone. I will require multiple hands. Therefore, the problem becomes inherently multidisciplinary, and all of that will happen. And at the end of doing all that research, you will have something to show. And if you come across a good student who wants to take it to the market, to a startup, well and good. There will be PhD students becoming entrepreneurs. They will provide jobs for other PhD students. Otherwise, who is going to give jobs for all the PhDs that we are graduating right now, in the country? And I think, I see a bright future. All that I think is required is, at the end of the day, a little bit of, that mindset change. I will stop here. I will unshare my presentation. Thank you very much.
Yeah, thank you, sir, for your nice presentation, and it's indeed very insightful. So probably I'll take some few questions, although we are running out of time, but I would like to take few questions from the participants. They can, yeah. Dr. Shantan, you can please go ahead with your question.
First of all, sir, this was a very nice talk, really enlightening, and thanks for this nice talk. And I would also like to thank Mitri for arranging this kind of great talk. And sir, actually, I have two questions. So one, for the first question is that while we are at the very beginning of our career, like whether as a young faculty or something like this, and then we are, let's say, working on some research problem, and then what I think that the more emphasis is given in the publication, because for our every year, or the reprisal or our promotion and other things, that number of publications, quality of publications, which matters. So I would like to see your view that what do you think that from the putting our effort in the technology development side from the very beginning, how much good idea is that, or we should work for some time, and after we get some really good research results or some initial data, and then we should target for that.
No, that's a good question. No, I understand, because That's a question that many people ask. Initial stages, you need to build a profile. Nobody even wants to, all the product development kind of a work requires a multidisciplinary research. And why would somebody come and work with you? They will only work with you when they see that you are a good researcher. And how do you judge a good researcher? You have to publish good papers. If you have published in some unknown, some predatory journal, nobody is eager to work with you and then join hands with you and all of that. I think I would say that wherever you join, the initial phase is to be counted among the best researchers in that institution or in the country. And once you do that, then you should start looking at now of course now I am publishing now that process will happen in any case. And now I want to start protecting IP patents. You should start filing from the beginning anyway. But once you have enough of papers, and once you start filing patents, once it becomes part of the culture in your group, and at some point, you need to orient your work towards building prototypes, and then the multidisciplinary things will come into picture. Because from the beginning, from day one as an assistant professor, from the first year, if all your research involves 5 different departments and 5 researchers, it's people will say he doesn't do anything on his own or her own. For everything the person requires somebody else, and every paper will have 10 authors, then you will suffer. I have known people, where people are developing products, successful products in the market, but cannot become professors because they don't even meet the requirements required to become a professor in those institutions. And so therefore department, there is a lot of negativity. The person says, I'm doing so well, nobody in the department is doing or done anything that I have done. These guys don't understand my work, and a lot of negativity, and you can't live in that negative kind of a mindset. So my advice to all of you young people is, I think build a profile, write good papers, first be counted as a good researcher, keep protecting your IP wherever possible, and then slowly, once you start getting recognitions for your research, that is when you start to orient your work more towards developing a prototype and all of that. So there is a time for everything. Now if I only publish papers from day one to my retirement year, I have done nothing. I will, what difference will it make whether I have written 400 papers or 500 papers if those papers really don't add up to anything? So therefore there are different stages in life when you need to do different things. So therefore always do that. So never be always be patient. Don't rush up and then get into other kinds of problems. I did not do that when I joined IIT Bombay in 98 to 2005. If you see my profile, I wrote at least 30 papers in a year. And so I got Swarna Jayanti, Bhatnagar in 2005. Then I knew that, I will be able to publish papers. The world, I've convinced the institute that I'm a good researcher. Then people started interacting with me. Then I started orienting my work more towards products and all of that. Now after 15 years, I can say that I have done all of that. So I still write enough papers. I filed enough patents. So I think, that is how you need to do things.
Yes, sir. Thank you, sir. It clearly answers my question. My second question is, if I have time. So the second question is, while we see it, like currently the more importance is given to indigenous technologies. Now let's say there are lots of technologies which we import. Now let's say there is something which is the technology is not as such an innovation, but it is not done in India. Okay, so it is done somewhere in US or in Europe, and then we buy very high cost equipments or technology from there. We import that. Now, if we try to make those kind of technologies here, the first question is whether will that be useful, and second thing is that if something is open in the market, like the technology is open, but ultimately somehow in Indian industry this is not happening.
I understand what you're saying. So again, there are if you look at ISRO, right? Yeah, there are at least 3 or 4 other countries which are flying satellites, right? They are not right. There is nothing ISRO has done which other countries have not done, right? I mean, but that is indigenization. Even DRDO, what is that weaponry we have developed which no other country has? Nothing. We have, that's indigenization. For ISRO, for DRDO, doing that indigenously at a cost which is 1/10 of what it costs outside, that is good for them, I think, which they should do. But at some point they also need to be leaders. They cannot just be followers. But for us, I'm not sure which institute you come from, but I tell, faculty, wherever
I'm from Isar Gopal.
that's good. For
Same.
people like ISES, IITs, IAC, if we do indigenization, then there is a problem in the country. Now, who will do innovation? And if all of us are just, replicating things in a cheaper and low cost way, then there is no purpose for us to be working in these institutions. So I think some of us need to do things which are unique, which are first time in the world. When we took up that cardiac diagnostic project, there was nothing in the world anywhere, like that. When you took up that explosive detector, there are explosive detectors, but they are all based on spectroscopy kind of principles and based on the chemical coatings and all that. There is no explosive detector which is based on a micro electromechanical system on the deflagration principle. Ours is the unique and a disruptive product in that space which nobody else has in the world. And that is the uniqueness. But that took us 10 years of time to get it. But they are the kinds of innovations we must be focusing on. And if you are developing agricultural sensor, develop an NPK sensor, which is electrochemistry based, which a villager, can take it to the field and do the measurements without any mistakes. I think that is innovation, because there is nothing like that available. They still use very expensive technologies to detect those. I think there are lots of places where you can innovate, develop those unique products which have a world market, and that is the kind of things I want to see in our academic institution. Then you can write papers. Otherwise, you are building, let us say, a solar lamp, and you want to do that because other solar lamps are very expensive. What paper can you write out of that? You can sell it for 10 rupees, but then nobody is going to respect you for doing anything like that. So I think we need to choose problems very rightly, very carefully. And if you do that, I think all these problems require deep technology to solve. They are not easy problems. And but that's where innovation, that's where you can write papers and file patents and all of that.
Thank you,
sir, for your kind answers. I think Alexander also had a similar question. He wrote in chat, can professor throw more light on how and when exactly to begin the patent process and when researching?
I think, before at IIT Delhi, I tell faculty, if you have a paper, just wait for a month. If you think there is something new in that, wait for a month, give that paper to a cell we have here, and that cell will employ lawyers. They will convert your paper to a patent. Within a month, they should file that patent, if not a provisional patent, and then you can go ahead with your publication. If you tell a researcher, you wait for 6 months until I file my patent, then nobody is going to wait, because there are PhD students, the guys or those people need to graduate. I think it doesn't again work that way. So I think you need to file patents wherever it's possible. We, as India, we need to file more patents from our academic institutions. At IIT Delhi, 2016, before 2016, if you look at, IIT Delhi was filing 15-20 patents per year. Now in 2020, despite COVID, we filed 160 patents in that year. Now in 2021, I hope we will file 200 patents kind of a thing. I think so that is a kind of a growth possible. From 10 times more patents in 5 years is definitely possible in our academic institution. So we need to protect more IP, which unfortunately we are not doing, because we are in a rush to publish papers and nobody wants to wait even for a month to file that patent. And we must do that. Otherwise, things will not change, unfortunately.
Thank you, sir. Thank you very much for the response. So I have a very small question. In one slide, you said that there are some solutions looking for some problems. So what can you give some example, like when you say that, what exactly does that mean?
Very often, how do we do research today, right? Every research, you are solving a problem, right? So when you, in every research, you get a DST project, you write a proposal, get a DST project, and the DST says excellent progress, and you have, meaning you have provided a solution. But where are you going to apply that? So now you are looking at, where can I apply my solution? So that is what I meant. You have solutions which are now looking for a problem where you can apply. There are so many algorithms, so much of theory our people do, but they don't know where to apply that theory finally. So that kind of research happens a lot in our institutions. So lots of solutions everywhere, but because they have not done a top-down kind of a thing, they have not thought about the complete product as a solution. They have done some piece of work, but then you are always struggling to find out what can I do with that. So let's say somebody has developed a nano material, that has certain properties. Now you synthesized and you developed, you published it. So now we don't know what do I do with these nanomaterials. So now you are trying to find a problem where I can use these nanomaterials. That kind of approach is very difficult to get anything out eventually. So.
Okay. Okay. Maybe I'll take one last question. Shashwat asked one question. So it's like how to reduce the time between indigenous work and innovative work, considering we need to start with building the ecosystem first before innovating.
It's a challenge, it's like I said, that patience is important. It takes time, nothing happens overnight. All of us, I have what the presentation that I have showed you, I have those slides, starting from 20 years ago. So even 2004, I could have shown some of those slides. Each slide there is actually a PhD thesis. So it takes time, to build a complete product and to get it out into the market. It takes time. We need patience. But my first product took 10 years, right, in my group. But the second one we could do it in about 4 to 5 years. Now, if I have to do something again, today I can do it in 3 to 4 years. And I think but that's a minimum time required, because anything faster than that is difficult. And I think you need to have patience.
Yeah. Thank you, sir. So I think we are at the very last part of our webinar. So I would like to thank Professor Rao for his time and this very interesting talk. Thanks to all the participants for joining the webinar. I would also like to thank IEEE Censors Council, YP members, IEEE Region 8 young professionals, Brooke and Omar especially, for publicity and relevant activities. So thank you, sir, for joining us. Hope to see you soon again somewhere.
Thank you. Thank you.
Thank you, sir. Yes, thank you.